Hello, so we're going to work through an example problem in kinematics today. So this example problem has two parts and we're going to work on both of them. So briefly, kinematics is the study of how objects move and specifically predicting how they will move in the future. So we are given certain information and our goal is to calculate the other information based on what we're given. So we can jump right into this problem. So the problem says a car traveling at 38 meters per second slows to a stop in 4.2 seconds. So that is our basic information, and then they're asking us two questions. What is the car's acceleration? So during that time period, how much does the car slow down? And how far did the car travel until it came to a stop? So we're going to work on part A first. So as with any problem, we're going to follow the process of reading the problem, writing down what we know, and then drawing a picture. So for part A, let's read through and figure out what we know. A car traveling at 38 meters per second. So we know at the beginning of this problem, the car is traveling at 38 meters per second. So since we start off like that, it means our initial velocity, v sub I, is equal to 38 meters per second. Okay, let's continue. Slows to a stop. There aren't any numbers in this, but there's actually some information in this phrase, slows to a stop. When something goes to a stop, that means at the end of that period, it's not moving. Another way of saying that is at the end of the time period, its final velocity is 0. So that's our second bit of information here. V sub f equals 0 meters per second. Okay, let's continue reading. In 4.2 seconds. So that tells us something else. Our time, our elapsed time, pardon me, is 4.2 seconds. It takes 4.2 seconds for the car to go from 38 meters a second to 0 meters a second. So, let's see what it's asking. So part A is asking, what is the car's acceleration? Or A equals question mark. That's what we want to find out right there. So let's draw a picture of this scenario. So we have our car here, and we know that at the beginning, the car is moving at some speed vi. And at the end of our time period, the car is not moving. So vf equals 0. So it goes that way, and it slows to a stop over the course of 4.2 seconds. So I'm going to write in what we know our VI to be, which is 38 meters per second. I'm going to write in units here as well. So let's think about this. There are a couple different ways to predict what our answer is going to be. So the first thing we're going to do is solve this equation here. We're going to select an equation and solve it. And then we're going to work through the picture representation. So now, once we have read the problem, written down what we know, and drawn our picture, now we're going to select one of these equations. So we need to select an equation that has all of these variables in it and nothing more. So we want an equation that has both velocities, time, and acceleration, but not displacement, because we don't know what displacement is. So let's look through. Oh, our first equation seems to work pretty well for that. It has both velocities, acceleration, and time. That one seems to work pretty well, so we're going to use that one. So now what we do is we write out that equation. V sub f equals V sub I plus A times t. And now we're going to rearrange this equation to solve for a, because a is what we want to find here. A is our goal. So let's rearrange this equation. The first thing we can do is subtract vi from both sides. So we have vf minus vi is equal to a times t. Okay, and then we can divide both sides by t. So we have vf minus vi, all of that divided by t, is equal to a, because the t's canceled out here. So this equation tells us what we want. We're going to write it again over here. So we have a equals, I'm just flipping the sides now, a equals vf minus vi over t. So at this point, let's plug in our numbers. We know that vf, we know that vf is equal to 0. So we have 0 meters per second minus our vi is 38 meters per second divided by our time, our elapsed time, which is 4.2 seconds. So this is going to be our acceleration. So let's simplify this. We know that our acceleration is going to be equal to negative 38 over 4.2. That's the number part of our acceleration. And now let's look at the units. We have, in this part, we have meters per second divided by seconds. That's the same thing as multiplying by 1 over seconds, which is the same thing as meters per second squared. So we know our unit is going to be meters per second squared, and then we can figure out what the actual number is by pulling out our calculator here. 38 divided by 4.2. So 38 divided by 4.2 is 9.0. Remember, we have, the number goes on longer than that, but we're only given 2 significant figures. So 38 and 4.2. So we only want 2 significant figures in our answer. So 9.0 meters per second squared, but we have to remember this negative sign. It's a negative 9.0. So that is our answer right there. A equals negative 9.0 meters per second squared. So let's go back to our picture. If we have, what does it mean that this acceleration is negative? Well, all that means is that the acceleration is pointing backwards. So it's pointing to the left. If this side is our positive and that's our negative, a negative acceleration means an acceleration that is pointing that way. And that makes sense, because if you start off with a velocity that's pointing to the right, so if you start off with a velocity going that way, and it eventually stops, the force going opposite it has to be pointing the other way. So that makes sense. That is a reasonable answer. Okay, now that we have our answer for part A, let's look at part B. So we're going to do the same process. We're going to read the problem, write out what we know, and then come to an answer. Actually, let me think about this. Yeah, no, we're just going to do it on the same board. So how far did the car travel until it came to a stop? Okay, so how far did the car travel? It looks like it's asking for displacement here. So at this point, this whole segment of information that we had for part A is still true. So we can copy it over. So we're going to write down what we know. We know VI equals 38 meters per second. We know VF equals 0 meters per second. We know our time is equal to 4.2 seconds. And here's our extra bit of information. Our acceleration, which we found earlier, is equal to negative 9.0 meters per second squared. So part B is asking us for displacement. So we're going to write d equals question mark. We don't know what it is, we're trying to find it. So we've read the problem, we've written down what we know, we're going to draw another picture. Or we can just add on to this same picture. So what we're trying to figure out here, it's the same situation, so we can keep the same picture. All we're trying to figure out right here is this distance. It's the distance between when we start looking at the car and the time it stops, when it's no longer moving. And that's going to be our d. So now we get to choose one of these equations. We're in a special situation here because we have all of the variables. Everything. All of the variables in here we have. So we can choose any of these equations that we want to. I think we're going to choose this one because it's my favorite. So this equation tells us d equals vi times t, so vit plus 1/2 at squared. So now that we have our equation, the reason I chose this one is because it's already solved for us. We're trying to figure out d, and d is already on its own on the left side of the equation. So all we have to do is plug in our numbers. D is equal to, so vi is 38 meters per second times t, which is 4.2 seconds. Okay, then plus 1/2 times our acceleration, negative 9.0 meters per second squared, times our time squared, so t squared, so that's times 4.2 seconds squared. So that is our equation. That looks like a pain to calculate, which again is why I have a calculator. Should really always use a calculator because by this point you know how to add, subtract, multiply, and divide numbers. I trust you on that, and it's silly to just make simple arithmetic mistakes by doing this by hand. So use your calculator for this. So our calculator tells us 38 times 4.2 is equal to 159.6. And the units are meters per second times seconds, so their seconds cancel out, and we just have meters. So 159.6 meters plus, now let's evaluate this. First thing, let's square 4.2, so that's 4.2 times 4.2. That gives us 17.6. We're then going to multiply that by negative 9, which gives us negative 158. Then we're going to multiply that by 1/2, so times 0.5. And that gives us negative 79.38. Now let's look at our units. We have meters per second squared, and then we have seconds squared. So the seconds squared cancel out, and we have meters. So now all we have to do, notice since we have plus a negative, just erase that and write minus. Now we just have to calculate this. So we have 159.6 minus 79.38, and that gives us 80.22. But remember, we only have two significant figures, so our number is just 80 meters, or just 80 meters. 80 meters is our answer. Notice we didn't round in the middle. You only apply significant figures at the end of a problem. So that's what we have. Our distance, or our displacement, is 80 meters. So we can fill in the last bit of our diagram here. D equals 80 meters. So that is the general approach to solving these type of kinematic problems. When you're given information and you're asked to find other information about its movement. So, just to run through the general process, again, with any problem that you're going to run into, you read the problem, you write down what you know, then you draw a picture. The picture is not necessarily as important right now, but it will be helpful with more complicated problems. So, read the problem, write down what you know, draw a picture, then, based on the variables that you have, you choose one of these equations, you rearrange it to solve for the variable you're trying to find, then plug in the numbers, and make sure you have your units. And that will give you the answer every time. So, our two answers for parts A and B were negative 9.0 meters per second squared and 80 meters. So that is how you solve a kinematics problem, and I hope that helped.